Ready to see the results of the mission? Take a peek. So the first analysis shows samples that contain abundant water in the form of hydrated as both minerals and organic molecules. And at nearly 5% carbon by weight, carbon being the central element of life, a far exceeding our goal of 60 grams. This is the biggest carbon-rich asteroid sample ever returned to Earth. And why are we doing this? Because at NASA, we are trying to find out who we are, what we are, where we came from. And this mission will help our scientists investigate planet formation for generations to come. And it's going to deepen our understanding of our solar system.
That nitrogen flow attached, the next day, Monday, September 25th, it was flown from Utah to Ellington Air Force Base and brought here to building those parts off to get a little further in so that we can then distribute that sample into bulk sample handling trays, which are triangular and look sort of like deep dish.
Bounty of sample on our hands already, and we're not even inside of TAG-SAM. The views here are amazing of this sample, and they're only...
The science canister, that's like the vault that protected the sample on the return journey home. And sitting inside there is the TAG-SAM. That's the device that actually touched the surface of Bennu, collected sample, kind of like a vacuum cleaner. The first panel there in the upper left, those are the water-bearing clay minerals, and they have this fibrous kind of structure. We call this serpentine because they look like serpents or snakes inside the sample. And they have water, X-ray computed tomography. It's like a CAT scan. So without cutting into the rock, we can actually look inside. We can see the textures and the distributions of the minerals. This helps us intelligently select areas where we want to make cuts so that we get the most exciting science results. It also gives us a good sense of the size and shape of the particle. This is the biggest one. It's about 2 millimeters across. And you can see here in red those sulfide minerals. And then finally, the last panel there, panel E, just shows two very different kinds of rocks sitting next to each other. One of our key
there in the center, just to the right, the kind of a light bluish fluorescence, that's from a carbonate mineral, so carbon locked up in this mineral grain. But then you see these small specks of light, looks like stars, right, glowing. This is organic matter.
And in just a few moments, we're going to reach peak heating and peak deceleration. That's at 32 g-forces, punishing g-force on our SRC, a phenomenal view of that streaking SRC coming in across the sky. That parachute deployment was given internally by the spacecraft. All of what you're seeing now is autonomous on board that SRC. The team on the WB-57 doing
DDL milestone, we have touchdown. I repeat, DDL, SRC has touchdown.
And touchdown of the OSIRIS-REx sample return capsule. A journey of 1 billion miles to Asteroid Bennu and back has come to an end. Approach this sample, check the area for any unexploded ordnances, UXOs, that could possibly be out there on the range. As I mentioned, that first person on scene will be the on-scene commander, Stu Wiley. He'll be doing an environmental sweep. We're getting a nice close-up view. You can see the parachute disconnected. You can see some of the wiring of it. There, just a little, are pieces of the asteroid Bennu. We'll be getting access to those samples in just a few days and actually seeing exactly what we got from the asteroid regolith. This
Helo 1 has landed at the recovery site.
So our first helicopter, you just heard confirmation, and you can see visual confirmation of that landing. We're maybe about 100, 200 feet away.